Okay, and so we're trying to find the specific heat of this metal that we're going to put in the water. We have it, so we're trying to find C, so we need Q over M delta T, mass, and change in temperature are easy to find. What about this Q? There's no utensil we have that can just measure how much energy was either gained or lost by the metal. We need to do it in context, and this is where the water comes in. Okay, so we know the specific heat of water. We can measure the mass of the water. We can measure the initial and final temperature of the water. And so with that, what we can calculate for the water is the Q, mc delta T. How does that help us? Okay, so let's say this temperature, this one starts at, let's say it's 50 grams. Okay, starts at, let's start with a hot piece of metal. Let's start it at 97 degrees Celsius. Okay, over here, let's say we have 150 grams of water. Let's say it starts at 23 degrees Celsius. Okay, what's going to happen when we put them together? Well, temperature of the metal is going to go down, temperature of the water is going to go up until they come to the same final temperature. So when you put these together, we're going to have the same final temperature, which we can easily measure with our thermometer. Okay, so we have our mass of the water, we know our specific heat of the water, we have the final and initial temperature of the water. So let's say they equalize at 25.2 degrees Celsius. Okay, so what does that tell us about the water? So our Q, so our mass is 150, specific heat of 4.184, change in temperature, so this is, since we're looking at the Q of the water, this is the change in temperature of the water. So its final was 25.2 minus your initial of 23, so it's going to go up about 2.2. So this will be a positive value, meaning our Q will be a positive value. Okay, and the calculated value for this is going to be about 1380.72 joules. Okay, so why does that help us? Where does this energy come from? This is the energy gained by the water when we put the hot metal in there. So the energy gained by the water is coming from the metal. Assuming our cup is perfectly insulated, all of the energy lost by the metal is gained by the water. So this value would be related to the Q for the metal, which is what, this is our last remaining variable, is that Q. The only difference, again, I said the sign of Q tells you if it's gaining energy or losing energy. Well, in this case, the water was gaining energy, meaning the metal is losing energy. So the Q for the metal is not going to be 1380, it's going to be negative 1380.72 joules. Okay. And then it's going to, but then our delta T should be negative, right? Because our final is lower than our initial. Okay, so our mass, again, was 50 grams. And our delta T, so final minus initial, 25.2 minus 97. Okay, so this is a negative value, this is a negative value. That makes sense, so our C should be always be a positive value. Okay, so when we do this, we get a value for our specific heat of about 0.386. Okay, so that is our specific heat for the metal based on the experimental data I just made up here. Okay, and so a couple things about this. This makes sense. First of all, it's a lower value for our metal. Metal should have a lower specific heat than water. It's going to take less energy to change their temperature in this case. Okay, you could do this theoretically with hot water, cold metal. The sign of the transfer is going to be a little bit different. Okay, let's take a look at another aspect of energy here. So when we heat up, we're talking about ice, but water in all phases: ice, liquid, water vapor. This is what happens when we start adding energy to it versus what happens to the temperature. And for a lot of these parts, we see what we'd expect. So from here to here, here to here, and here beyond, we add energy, we change the temperature, right? So we're adding energy that increases the kinetic energy, increases the temperature of our substance. So in these spots, we're going by Q is equal to mc delta T. Okay? That's not different at this point. What is different is going to be what's going on here. So we have, at this point, we're adding energy, yet we're not changing our temperature.